In this video, we take a look at Intel OIDN Denoiser. OIDN is a CPU-based AI denoiser. It allows you to apply denoising interactively almost in real time like optics in the IPR or as a post-processing effect after the render is finished for the final render. But as it is faster and maybe less accurate compared to Arnold Denoiser, it is meant to be used for look-dev purposes while working in the IPR and not for denoising the final high-quality render. Yet, it's a really high-quality denoiser and can be relied on for final still renders. For animations, you still want to use a denoiser that offers temporal denoising like Arnold's own denoiser. Like any other Arnold imager, we can add it right from the render settings from the effect menu and change the imager type to Intel OIDN Denoiser. I tend to add my Arnold imagers right from the IPR, so let's delete it here and add an OIDN Denoiser imager from the Post tab in the IPR. Now, always remember, if you want to have multiple imagers like light mixer, exposure, tone mapping, and so on, the denoiser imagers should always be on top and the first imager in the list, as denoisers won't work properly after imagers have been applied to them. Now we can start the IPR. And if I start moving around in the scene, you can see OIDN denoises the image in real time like optics. In the previous update, I talked about optics denoiser imager. At that time, there was a bug and optics wouldn't apply denoising in real time, but that issue is fixed now and optics is a real-time denoiser as well. You notice denoising happens very quickly. At the beginning, we don't get a lot of details, but as we allow more samples per pixel, OIDN will resolve more details while keeping the render noise-free. OIDN can also denoise other AOVs. To do that, just go to the selection tab, and right now the AOVs to be denoised is set to only the beauty AOV, but I can change it to all, and that will denoise not only the beauty AOV but all of them. We already have diffuse direct and indirect as well as specular direct and indirect AOVs added. You can see if I start the IPR again and wait a bit, you notice the beauty AOV is denoised, and if I take a look at the diffuse and specular direct and indirect AOVs, they are denoised as well. Now, if we want to keep the original undenoised AOVs and save out the denoised AOVs to separate passes, we just have to enable this output to separate AOVs under the main tab. Now, for each AOV, a separate denoised AOV will be generated with the underscore denoised suffix. Let's run the IPR again. If I take a look at the AOVs drop down, we get our original undenoised AOVs and a separate denoised version for each one. For example, we get our original undenoised beauty and the denoised version, or the original diffuse indirect, which is very noisy, and the diffuse indirect denoised version. The only specific option to OIDN is this albedo field, which if kept as is, OIDN uses additional AOVs, in this case albedo AOV, to improve the quality of the denoising. As you feed more data to the denoiser, it will help with the amount of detail it can preserve. And the saving process is the same as the optics denoiser. You can check out the optics video in the first update for the course. So let's save some time. OIDN is one of the best denoisers I have ever used. Very fast, very functional, almost no artifacts in most cases, preserves a lot of details. Overall, a very useful addition to Arnold. So that's about Intel OIDN Denoiser. See you in the next one.